Hi guys, and welcome to our lesson on ATP. Now, nothing in life is free. Everything always costs money. And if it's not costing you money, then it's probably costing you something like your time or your energy. Money makes the world go around, and this principle also applies in the biochemical world. In biology, if you want to do anything, you got to pay for it. And so today we're going to talk about the money of the biochemical world, which is ATP. In this video, I'll introduce you to ATP, which is the currency of life. I'll tell you how our body uses ATP, but more importantly, I'll tell you how our body makes ATP, and we're going to profit in knowledge, in glory, and in the satisfaction of learning. So, ATP is the energy currency of the cell. Let me introduce you to the biochemical dollar. Here it is. This is ATP. ATP stands for adenosine triphosphate. The A in ATP stands for adenosine, and that's what I've represented with this big old hunk of a green rectangle. A for adenosine. Now, the P in ATP stands for phosphates, and there's three of them. Tri, so tri meaning three phosphates. Phosphate 1, phosphate 2, phosphate 3. And so this molecule you see here is ATP. Let me show you the chemical diagram for this. Remember, in organic chemistry, every single joining point is a carbon, where you don't see a letter. And so this complex over here with this nice pentagon, this pentagon and hexagon, this thing, that's the adenosine. And these three little P's with the O's sticking off them are the phosphates. Phosphate is PO4, and so that's 1 phosphate, 2 phosphate, 3 phosphate. And so this is what the chemical structure of ATP really looks like. But who cares? That's not important. Let's just stick with this simple diagram. Now, ATP. Where on earth is the energy in this molecule? Well, let me show you. If you look right here, if you look really, really closely, the bond here is where all the energy is found. In chemistry, when there is a bond between two molecules, that bond is made of electrons, and that is where energy is found. And any cellular activity that requires energy needs us to take the energy here in ATP and to release that. And that's how we get energy to power our biochemical reactions. So let me tell you how we use ATP. So ATP, adenosine triphosphate, the energy is found here in this bond, and we need to release that. So when we use ATP, what happens is that we release that, and I've represented that with this yellow zigzag, which means electricity. It's shocking. That's where the power comes from. And what we end up with when we break that bond is ADP, which stands for adenosine diphosphate, because now there are only two phosphates, and we get this free phosphate, usually represented as a P. Sometimes they chuck a little I there, which means inorganic. So ADP plus 1 phosphate, that's what happens when you split up this bond to liberate the energy that we can use. And what you end up with is ADP plus P. ATP, when it's used, becomes ADP plus P. And that's how you use ATP. Now, following this logic, I can tell you how we make ATP. So if we start with ADP, so adenosine with 2 phosphates, and we take another phosphate and we smash on there, well, you get ATP. And so that's how we make ATP. We're going to take 1 phosphate and stick it onto an ADP. And when we use it, we do the opposite. So metabolic biochemistry is all about getting rich quick and making lots and lots of ATP so that we can do all the things and be happy. If you want to move your muscles and go for a run and go to the gym and do a backflip, you need ATP. So how are we going to make a lot of ATP? Well, the way we make ATP is using food. Food is fuel. And so this is a meal I cooked the other day. This is quite a simple chicken recipe. I got some chicken thigh cutlets and marinated with a bit of lemon, put in some tomato paste and a few quick easy spices. I stole this recipe off Instagram, and then I chucked it in the oven and baked it for 40 minutes, and it was juicy and delicious. And I've served it here with some sauteed kale, colollini, and avocado. And there's some onions there as well. So food is fuel. And in this plate, we have a bunch of carbohydrates, fats, and proteins. So we talked about our macromolecules in the last video. This is where we're putting them into practice. So we've got this plate of food filled with carbs, fats, proteins, which is all fuel. And we're going to turn this fuel into lots of ATP. And all the biochemistry that we'll learn in the next two videos is all about how we turn fuel into ATP. So let me explain how we do that. Making ATP is a two-step process. So let me tell you the two steps. Step 1 is fuel oxidation, and step 2 is oxidative phosphorylation. So making ATP is a two-step process. In step 1, fuel oxidation, we're going to take our fuel, which is our carbs and fats mainly, and we're going to rip out all of their electrons. Okay, we're going to rip out all the electrons from our fuel. And then in step 2, oxidative phosphorylation, we're going to take these electrons and react them slowly with oxygen to create a huge amount of ATP. So, two steps. Fuel oxidation, where we rip out the electrons from our fuel, and step 2, oxidative phosphorylation, where we take these electrons and react them with oxygen to create ATP. So let me illustrate that for you. Step 1, fuel oxidation, we're going to get our fuel, and our body is going to perform a series of biochemical reactions, which we call fuel oxidation reactions, and that's going to take the fuel and turn it into carbon dioxide. And in doing so, we rip out all their electrons. So these little green dots here are the electrons that we've ripped out from our fuel. And then the carbons become carbon dioxide. Great. Now we take these electrons and feed it into step 2, oxidative phosphorylation. So this is our ATP making factory in the mitochondria, right? And we'll explain all of this in our oxidative phosphorylation lesson. But this is the ATP factory, and we're going to use these electrons and feed it into this machine, and it's going to make lots and lots and lots of ATP. Let me tell you the difference between these two steps. The first step, fuel oxidation, will make a tiny amount of ATP. When we do fuel oxidation, we'll make a very, very small amount of ATP, and our body can do that very quickly. In step 2, we're going to make a huge amount of ATP, a huge amount, but this happens very slowly, okay? This first step is what is known as our anaerobic energy system. It does not take any oxygen. There is no oxygen involved in this process. The second step is called our aerobic energy system. Here we're reacting the electrons with oxygen, and we're going to make lots and lots of ATP, and that's what we call our aerobic energy system. So for example, if you go for a quick sprint of 20 seconds right now, you'll probably burn a lot of fuel and make a small amount of ATP very, very fast, but that won't keep you going for long. But if you went for a half an hour jog, this second system would kick in, your aerobic energy system, and that makes lots of ATP, and that means you can keep on running for half an hour. And so overall, these are the two steps of making ATP. First step is fuel oxidation, where we rip out the electrons from our fuel, and the second step is oxidative phosphorylation, where we feed the electrons into our ATP making factory to make lots of ATP. And that's it. This is an overview of our strategy, and in the next two videos, we're going to talk all about how this happens. Firstly, fuel oxidation, and secondly, oxidative phosphorylation. Here's the summary in the text. You can read that in your own time, and I'll see you in the next video.